Hello students, welcome back. In this video, I'm going to solve some questions from Grignard reagent so that we will cover almost all the concepts from the Grignard reagent and you will be ready for your upcoming exam. The first question is about the hydration of an alkyne molecule which is also having ketone functional group within the molecule. Whenever we see this reaction condition of an alkyne and mercury sulfate in sulfuric acid, remember this is hydration of the alkyne molecule. When we add water molecule directly to this triple bond, the reaction will not happen because water is also electron rich due to lone pair of electrons, and due to two pi bonds, this is also electron rich. Electron rich will repel each other. Therefore, we need some medium which will catalyze this reaction. So for that, we use the mercury sulfate in sulfuric acid. Ultimately, what we are doing, we are adding water with respect to Markovnikov's addition. What does that mean? The hydrogen goes to the carbon with more number of hydrogens directly attached to it. And what about the OH? OH goes to the carbon with no hydrogens attached to it in this case. So what we are going to get in the first step, you can see that you are going to get enol. And you see enols are not stable because they can undergo tautomerization. So this is a tautomerization happening and we are going to get ketone. So there is a cyclohexanone which in turn again attached to a ketone like this. And what is this? This is product A. Now, this is treated with 2 moles of Grignard reagent. The Grignard reagent can act as a nucleophile as well as a base. If there is electrophilic carbon in the molecule, it prefers to act as a nucleophile. You have 2 electrophilic carbons here. The ketone carbon here and ketone carbon here. And how many moles we have? 2 moles. So in both the cases, the addition will take place like this. Since they are ketones, they are going to form tertiary alcohol. You're going to get OMGBr, but there is a hydrolysis at the last step. So what we are going to get? OH. The methyl is attacking here. Similarly, here also, you see OMGBr will get hydrolyzed and it will become OH. Already there is a methyl group and the Grignard reagent is attacking here means it's also a tertiary alcohol. So look for 2 tertiary alcohol containing molecule in the options. Just check here. You see this is also tertiary. This is also tertiary. Therefore, the final answer is 1. Why not this? Because this is secondary, not correct. And you see there are ketones retained here, not possible. Hence, the final answer is 1. Now let's check for the second question. There is 1,3 dibromopropane molecule. It is treated with only 1 mole of magnesium ether. You have to consider it as 1 mole because excess is not mentioned in the question. So what will happen now? The magnesium will get inserted either here or here, doesn't matter because the molecule is symmetrical. So what you are going to get here? MgBr. This bromine will remain as it is. You see there are 3 carbons, 1, 2, 3 like this. Is this our final product and is 2 is the correct answer? No, because within the molecule you have 2 reactive centers. So you see this is the Grignard reagent. It will attack the electrophilic carbon and the bromine will leave. So since it is intramolecular reaction, you're going to get a cyclic product. And what is the cyclic product are we going to get here? Cyclopropane. Therefore, the final answer is option 3. Now let's solve the next question. There is a dibromo-nitrobenzene molecule and magnesium ether is given. Again, it is only 1 mole. What should be the product A? What many students assume is that this is a method of preparation of Grignard reagent and the magnesium will get inserted either here or here. They will directly jump into preparing the Grignard reagent. But you should not do that. Why so? Because observe this group. Nitro is an electron withdrawing group. Whenever there is an electron withdrawing group within the molecule, you cannot prepare Grignard reagent. Why is it so? Because the formed Grignard reagent, say for example, in this case, let's assume the Grignard reagent is formed with respect to this carbon and bromine bond, say here like this, then what happens? Since we have a nucleophile within the molecule, it will react with the electron withdrawing group and it will reduce this nitro to nitro. So there is a possibility of reacting within the molecule. That's why whenever there is an electron withdrawing group like nitro, aldehyde, ketone, ester, we cannot prepare the Grignard reagent. Say if there is an aldehyde, we will end up with an alcohol. Same with the ketone and esters. That's why this reaction is not recommended. What many students assume is that the moment we form the Grignard reagent here, the negative charge will be stabilized by the nitro group. Hence, the answer might be 3. No, that is not correct. None of these will be formed in the reaction. Hence, option 4 is the correct one. Let's find out what is the final product C for the series of reaction. The first molecule is ethine molecule and it is treated with only 1 mole of Grignard reagent. As I told you, the Grignard reagent can act as a nucleophile or a base, but alkynes are already electron rich. That means what? This is also electron rich. It cannot attack the triple bond, but rather what it does is it will pick up the acidic proton. The terminal alkynes are acidic in nature because of the sp hybridized carbon. The sp hybridized carbon, due to more s character, they are electronegative in nature. Because it is electronegative, the hydrogen here will be electropositive. That means what? This is a weak acid. If this is an acid, this will act as a base and it will abstract this proton. So what will happen when CH3 minus takes the proton? It will become CH4. It is a gas. It will escape. Now what happens to this molecule? It's going to form one more Grignard reagent. Why did I call this as one more Grignard reagent? You see, the alkyl part is attached to the magnesium directly. That means what? This is also a Grignard reagent. So preparing a Grignard reagent from one more Grignard reagent is also called as cross Grignard reaction. So this will be our product A. This is treated with carbon dioxide. So this is nothing but carboxylation reaction. How so? You see this is electrophilic carbon. The minus will attack here. Oxygen will take away the electron. So product are we going to get? The carbon will attack here. That means C. This double bond will remain as it is, CO. And what about this? OMGBr. Now the question is this Grignard reagent? No, because oxygen is attached to magnesium but not carbon directly. Hence this is not Grignard reagent. You see there is water at the end of the reaction. That means we are hydrolyzing this part and we are going to get carboxylic acid. This B is treated with mercury sulfate in sulfuric acid. I have already told you what is the purpose of this reaction condition, but there is additional information here. See, whenever we have carbon-carbon triple bond with electron withdrawing group, it will not obey Marconi-Cau's, it will obey anti-Marconi-Cau's addition of water. Why is it so? If the hydrogen goes here, the carbocation will be formed on this carbon, will be destabilized by this carboxylic acid. Hence, it will undergo anti-Marconi-Cau's. That means what? Hydrogen goes here, OH goes here. So, how are we going to write the product? So, this will be OH, double bond is here, CH, COOH. And this is enol. You can tautomerize this. So you are going to get an aldehyde over here, then CH2, then COOH like this. So this is 2-formyl ethanoic acid. And where is it? In option 1. Therefore, that is the final answer. Now let's solve the last question. This is a little bit tricky. So let me explain this in detail. We have a phenyl isocyanide molecule. Phenyl isocyanide is an isomer of nitrile compound. So nitrogen here is tetravalent, that's why plus charge. Carbon is trivalent, that's why there is a negative charge. When it is treated with benzyl magnesium bromide, what reaction should happen? First, the negative part of the carbon will interact with the magnesium bromide. So you can write a bond between this carbon and MgBr, right? So the nitrogen, which is electronegative element, it cannot withstand the positive charge. Therefore, it will take away the bonding electrons, the pi electrons. Then what happens? You see, the triple bond will become double bond, and carbon, which was having 4 bond, now it is having only 3 bonds. So what should be the charge now? Plus. And this plus will be attacked by what? Benzyl anion. So whatever benzyl anion is there, it's going to attack here like this. And then what are we going to get? You can write like this. So CH2, you can write this simply as phenyl. Okay, here MgBr like this. And when it is hydrolyzed, always we remove MgBr by H. We always replace it by H. So you just write down the H here like this. And check where do we have it? Phenyl, nitrogen, double bond, then CH to PH. Nothing but fourth option. Students, now is the time for you to solve some questions from the Grignard reagents. Please do solve them and comment your answers to know the key answers. Thank you.